All right, so we're just a few minutes after 10, so we can go ahead and get started. Everyone else can start, filtering in when they arrive. But I do have again Christy Rosati, the Field Application Engineer from Bussmann. This is the third and final part of the three-part series that she has been conducting over the past few weeks. And today she's going to be going over increasing panel SCCR. So Christy, whenever you're ready, you can go ahead.
All right, thank you very much. As with prior presentations, if anybody has any questions along the way, please feel free to type it into the chat or take yourself off mute and ask the question. I really enjoy when these are engaged. So please feel free to ask any questions as you have it. So our agenda, we're going to very quickly review UL 508A, what we learned last week, just in case we forgot a little bit of it over the past week. And then we're going to do a component by component review of what's inside this panel. So we'll talk about some misapplications and proper application of components, and then methods that we could increase the SCCR of each of these components, and then we'll briefly talk about some overall SCCR strategies. So just a review of what we went over last week to determine the overall panel short circuit current rating, right? My panel SCCR was based on two components, either the short circuit current ratings or interrupting ratings. My breakers and my fuses, those have interrupting ratings, and that interrupting rating cannot be changed, right? I can't use any upstream devices to increase my interrupting rating. The short circuit current rating of my panel will never be higher than my lowest interrupting rating, even if I got 17 current limiting fuses in front of it. And then I've got short circuit current ratings for pretty much everything else in my panel, power distribution box drives, etc. And these can change, right? Because these are dependent on what that upstream device is. So I can use, fuses instead of breakers, or I can use a device that it's rated for instead of. So short circuit current ratings are variable, whereas interrupting ratings are not. And these values are what's going to help me determine my panel short circuit current rating. Right, and then the 4 steps to how I determine my overall panel short circuit current rating, right? The first was to determine the short circuit current rating of each branch circuit. Second was to determine the SCCR for any of my feeder components. Step 3, identify my interrupting ratings for every overcurrent protected device. The big one there I don't want to forget about is the primary protection for my control circuit. And then finally, the SCCR, right, is the lowest value from steps 1 through 3. And then I just want to remind you, right, if you remember, step 1 had 2 parts here, right? We identified the short circuit current ratings for each of my branch circuits, and then I can see if I can raise that SCCR using feeder components. And the important thing here is this is something in my feeder helping my branch. So this is not a branch device helping my branch. It's not a feeder device helping a feeder. It's only if I have a current limiting device in my feeder, so current limiting breaker, current limiting fuse, that can help me raise my branch short circuit current rating, right? That's the most sort of complicated part of UL 508A, and we'll actually sort of see another example of it as we go through here. So the example that we had last week was this panel right here, and if you remember, I'm not going to go all the way through it, but right, we had 100 kA on this one branch, we had 22 kA on this branch, 14 kA in the power distribution block. The power distribution block was a little tricky because, right, it says that the default was 10 or it was 14 kA with a 125 amp breaker, and I used a 100 amp circuit breaker in front of it, so I can always use that smaller device in front of it, and that's fine. So that's a maximum value there. And then I had a 35 kA for my main breaker, and I had 10 kA as the primary protection for my control power transformer here, and my panel short circuit current rating was 10 kA. So that's the example we started with, or I guess we ended last week's presentation with. And this is the panel that we're going to go through this. We're going to basically go through each individual component here and individually raise the short circuit current rating. There's a couple different ways that we can do these, and we'll talk about sort of seeing that panel short circuit current rating, and my weakest link is what is rated 10 kA, and that's the that primary protection for my control power transformer. So what else can I use for control power transformer protection, right? What are all of my options there? So the first is exactly what I'm using right now, right? Is that a 10 kA breaker. Those miniature circuit breakers, you want to make sure if you do use them that you use the UL 489. Those 1077 supplemental protectors are not rated for primary protection. You can use them on the secondary of the transformer, but they are not rated for primary protection. So we can use, right, the UL 489 breakers there. The problem with those is pretty much all of those are rated 10 kA. Every once in a while you can find one that's 14 kA. Very limited applications usually for those. It's like just a couple amp ratings. That's not, very good if we need a 65K rated panel or something. So miniature circuit breakers are, very limiting to me if I use them in my panel. And I've had many an example of people who, they've got a lot of power supplies and they use these in front of power supplies, and that kind of just ruins the whole short circuit current rating of the panel. So be aware of that. Hypothetically, right, if I wanted a breaker with a higher interrupting rating, I could go to a molded case breaker. The only thing with a molded case breaker is, right, you're gonna pay quite a premium to go up to that molded case breaker there. The minimum amp rating for those is 15 amps. So, depending on the size of your transformer, depending on the size of your power supply, 15 amps might be way more than you need. A lot of times you only need, 6 or 9. So, how much protection are you actually getting out of a 15 amp breaker there? And of course, right, you pay more for the higher interrupting ratings, and to get it in that molded case frame instead. So it's technically an option. Probably makes more sense when you've got a whole lot larger of power supplies or control transformers there, just because of that 15 amp rating. I think really the best solution here is going to be fuses. So if you are using Bussmann fuses in front of a control power transformer, the FNQR fuse is the one you want to use. So an FNQR fuse is basically a specially designed fuse to be used in front of control power transformers. So when you have a control power transformer, that is the fuse you want to use. Now, if you're using it in front of a power supply, the LPCC would be fine. That's sort of the general purpose fuse, the yellow general purpose fuse that we have. That's good in front of a power supply. But in front of a control power transformer, FNQR, that's going to be the best for you, especially designed with that curve so you don't get any sort of nuisance opening with your inrush. Also, whenever you have fuses in front of transformers, you have a lot of options on basically what that fuse goes into, right? So a lot of times you can get that open holder, that sort of that first one shown there, that mounts right on top of the transformer, right? A lot of people love to use that. You put that right on top of the transformer, you take up no extra space in your panel. That is absolutely fine if you want to use one like that mounts right onto the transformer. Sometimes you can get finger safe covers for those. So if that's something that's important to you, you want to make sure you get that. Otherwise, obviously, without any sort of cover, it's not going to be finger safe. The next thing you can go to is, right, the next one on the list here, and I know that, Allen Bradley sells a version just like this as well, where it's a fuse holder, but it's got that rock out capability, right? You just sort of rock out those fuses to be able to take them out there. Really important thing to know about this, and I know that it's always written on these devices, in all caps letters, but small font, because everything is in a small font on one of these, is that this is not a load break rated switch. So really, really important, when you have a fuse holder that just has that rock out capability, that is a fuse holder. You are not supposed to be using that, to break a load. It is absolutely a shock hazard if you do. So whenever we use a fuse holder like that, we just really, really want to be careful that we're not using that as any sort of load break. I know that's really probably on the end user who's going to be doing that more than the manufacturer, but just know that that's sort of a risk in using something like that. Particularly, I think, in front of a control power transformer. I think that there are a lot of times where you have fuses in there and you never really need to use it as a disconnect, and it is absolutely a-okay to use a fuse holder like that in those scenarios. But in front of a control power transformer, right, what do we always, what's the easiest way to sort of fix something in our control circuit? It's to turn it off and turn it back on again, right? So having an actual switch there can be extremely valuable. So that's what that third product is. If you're familiar with that, that's the Bussmann CCP2. That is actually a UL98 switch. It's a load break rated switch. So you stick the fuses in to there, and overall you get a 200 kA rating and that load break capability. I really do recommend these. You know, they can be used anywhere you put fuses in your circuit, you know, for Class CC fuses for this specific one. But I really do think it's a great thing to use in front of your control power transformers, just because of how often that is used for switching capability. So to use it there as a switch, give it that rating to be used as a switch. Really great product. DIN rail mountable. It's pretty much the exact same frame size as that miniature circuit breaker. And you know, considering you're going from 10 kA to 200 kA there, the cost is really you know, kind of okay when you look at it. It's similar in price, in the price range of what you'd pay for that miniature circuit breaker, and you get 200 kA, right? It's going to be a little bit more because you're getting that 200 kA, but it's in the same sort of ballpark. So really great round one there. And again, use those FNQR fuses in front of there, and you'll run perfectly fine with a fuse in front of a control power transformer. So we're going to go ahead and replace that miniature circuit breaker with a Class CC fuse. Here it looks like we put one that mounts directly onto the transformer. Again, I would usually recommend that CCP2, so you have a switch, but we've put this one right on the transformer here. So if we do that, then that 10 kA breaker, that's no longer my weakest link, right? I've replaced that 10 kA. Now what's my weakest link? The power distribution block, right? We've got 14 kA limited there at my power distribution block. So let's take a moment here and talk about power distribution blocks. So one really important thing to know is that there are two different UL ratings that you can have on power distribution blocks. There's a UL 1953 listing, and then there's a UL 1059. And the difference between the two is what types of circuits they are permitted to be used in. So a UL 1953 listed power distribution block is rated for your feeder circuits, right? Which is pretty much where we're always using a power distribution block. There's a couple times we use it in a branch, but in that feeder, right? So if you have a situation where you've got that main breaker or main fuse disconnect and then a power distribution block and then all your branches, you must have a UL 1953 power distribution block there. What is the difference between the UL 1953 and the 1059? It has to do with spacing. So it doesn't have anything to do with finger safe or anything like that. It has to do with the spacing, the distance between the phases. So you can actually kind of see that in these two power distribution, the two open power distribution blocks. You can see there's space in between each of those poles, right? That gives you distance over air, distance over surface, you know, to make sure you don't get arcing between the phases. So UL 1953 is permitted to be used in those in feeder circuits, only those, and 1059 can only be used in branch circuits. So a UL 1059, the easiest way to tell the difference, I mean, you can look at the spacing, but if you don't really know what the spacing is, if you look at a UL 1953 power distribution block on the side, you see a UL listing on it. If you look on the side of a UL 1059, you see UL recognized. So this is actually only UL recognized because it is only permitted to be used in branch circuits. So the primary use for a 1059 terminal block is when you have group motor. So maybe you have one overcurrent protective device, a power distribution block, and then that goes to all of your motor controllers. That's one of the proper applications of a 1059. Or sometimes you see this actually like on the load side of your controller. So maybe you have a drive and you put these terminal blocks on the second, like, you know, downstream from those drives, so that when you hook up the machine, you just hook into one of these terminal blocks instead of wiring all the way into your drive. That's pretty much the two proper applications of the UL 1059. Really, really important. You don't want to be using the UL 1059 recognized block in your feeder circuits. It is absolutely a misapplication, and I think this is one of the most common misapplications I see. And a lot of this is just that if you don't know that there's a difference, if you don't know there's a difference between a UL 1953 power distribution block and a UL 1059 recognized one, you're probably going to use the 1059. The 1059 is smaller and it's less expensive. So if you don't realize that there's a reason it is smaller and less expensive and therefore not okay, then you're going to go ahead and use this in your feeder circuit. So this is, I think, probably the number one or two most common misapplication I see in panels. The only time you are permitted to use a 1059 terminal block in your feeder is in a single phase system, right? Because there's no distance between your phases that you have to worry about there. So then you can use 1059 in your feeder. If you have one that's modular, you can mount each pole 2 inches apart. That is going to take up a whole lot more space than just a 1953 power distribution block would. So those are your sort of your two ways that you can use the 1059 in your feeder circuit. But again, I would recommend just keeping with the 1953. So that's power distribution blocks. So first and foremost, right, two different UL listings. We want to make sure we're using the UL 1953 power distribution block whenever I'm in my feeder. Once I'm using that, now we got to talk about all of my ratings for power distribution blocks. So this, what I'm showing you right now, this is all for the exact same power distribution block. So you can see there's a lot of variability here. There's how many different short circuit current ratings are listed on here, all depending on what's upstream. So a power distribution block is going to have a default rating of 10 kA. If you remember from last week, that chart, it's a default rating of 10 kA, and then changing upstream depending on what we're using. So the good news is, right, so a lot of the Bussmann power distribution blocks do have ratings with some breakers. They have it with multiple manufacturers of breakers. The one I'm showing here is Eaton, but we have them listed with other manufacturers of breakers as well. But what you can see here is with the breaker. So in my first three, right, first three short circuit current ratings, I can hear, look at this overcurrent protection circuit breaker required. The first one listed there, it's the same part number, right? It's the same part number for all of those. It's my same maximum voltage, and it's my same, maximum amp rating, right? But I have three different short circuit current ratings possible, right? It could be 65, 42, or 14. How can it be three different short circuit current ratings when I'm using the exact same breaker in front of it? Well, it's because it depends on what load sized conductor I am using in this, right? So if I use between a number 4 and a number 6, I can get 65. If I use an 8, I get 42. If I use a 10, I can get 14. If I use a 12, I go back down to 10. If I use a 14, I go back down to 10, right? So my load side conductor, and this is not, unique to Bussmann power distribution blocks. A lot of power distribution blocks are this way, where depending on what load side conductor I'm using, it can change what the short circuit current rating of that is, even if I'm using the exact same breaker or fuse upstream from it. If you look down below is all of the ratings with fuses. And now these ratings get higher. We're talking 200 kA or 100 kA, right? But I can get 200 kA if I'm limited to a number 8, between a number 4 and a number 8. But to get 100 kA, I've got to be between a number 4 and a number 12, and my fuse size goes down. So it's really, really important, right, that I carefully look through every column of my power distribution block chart to see, where I wind up falling with these. So, hypothetically, let's just say we're going to keep with a breaker. We want to get to 65 kA in this panel, so we'll use the breaker that's listed here. It's a 65 kA rated breaker, 65, and that means, of course, here, right? So I put that 100 amp EG, right? So now I've upped the interrupting rating of this breaker, and now my SCCR is higher, but I have to use a number 6 wire, right? Or larger. And when I think about it, when I look at the rest of this panel, so I say, okay, I've got this in here, and now I got to use a number 6 wire. What am I going to? I'm going to a 15 amp Class CC fuse holder and a 15 amp breaker. Don't want to use a number 6 wire to go to 15 amp circuits. I don't even know if those will accept a number 6 wire, right? So you got to really be careful, right? You consider those gauge of wire and consider what it's going to. Now, if I were going to a large horsepower drive, no problem. But going to those two, again, you'd want to actually verify that those would accept a wire that, and then of course you're going to worry about your wire bending space. Number 6 wire, more expensive than a 10 or a 12, whatever you would actually use for this in the real world. So this is a solution, but it's not really a great one, right? So what else can we do here? And, you know, we could use a fuse with that upstream one, and we can certainly use smaller gauge wire, you know, once we go to a fuse disconnect. But another option is just not to use a power distribution block. And the way we do that is with power distribution fuse blocks. So this is a really, really great product that Bussmann makes. It's got 200 Ka SCCR. And what's the best thing about these is that it is 200 Ka short circuit current rating, period. There's no, it is this when you use this gauge wire, it's this when you use this. It's just, it's 200 Ka, period. So it's easy, right? You don't have to think through, you don't have to like scour those charts to make sure you're reading it right. You can get Class J up to 400 amps. You can get Class R up to 60 amps. And what else is really great is the ports on these are rated for dual wire. So you see this product, right? This looks like, I would say this is if a fuse holder and a power distribution block has had a baby, this is what you'd wind up with. It is just it's a fuse block with those multi-wire terminals on it. So you get your power distribution right there in your fuse block. And those ports, any of those little ports that you see in those are rated for dual wire. So it's actually rated for you to put 2 conductors in each. Now those conductors have to be between 10 and 14, and they have to be identical. So right, I could put 2 10s, 2 12s, 2 14s, but I couldn't put a 10 and a 14 in the same one. They'd have to be 2 identical wires though in there. And I can basically double the number of ports I have just by doing that, and the number of connections I can make. And so this is, you know, basically what the information looks for my power distribution block. I see, SCCR isn't listed on here. And again, that's because the SCCR is 200 no matter what, right? So there's no reading all of the columns and making sure you're doing it right. But I can get, right, this is a 100 amp and a 200 amp version, you know, of this fuse holder. You know, I can get 4 ports per pole or 6 ports per pole, depending on all of those. And again, you can see where in there in those load side conductors, I can get 2 copper between 10 and 14, again, as long as they're identical. So this is a fantastic product, right, to help you just get rid of that power distribution. The easiest way to get a high rating on a power distribution block is just don't even use one. So you could replace a power distribution block with this fusible power distribution block instead, right? And now a lot of times we might say, okay, well, the main disconnect, you know, if I'm using a main disconnect and a power distribution block in my panel, I'm usually using a fusible disconnect switch and a power distribution block, or a breaker and a power distribution block, right? That's a lot of times what I'm using. But if I'm using a you know, power distribution fuse block, well, I don't need overcurrent protective device in that disconnect anymore, right? I mean, granted, I would happily sell you fuses and fuses in a row. You fuse disconnect plus the fused the fusible power distribution, but you don't really need it, right? It would be redundant. Same thing, you don't need a breaker followed by fuses. So what you can use instead, if you're using the power distribution fuse blocks, so you can use a non-fuse disconnect as your main. A really cool thing about non-fuse disconnects is non-fuse disconnects, I should clarify, UL98 rated non-fuse disconnects are the only component where you are permitted to use downstream fuses to increase the short circuit current rating, right? Everything else, it's all about whatever is upstream from it. But with a non-fuse disconnect, you are allowed to use downstream fuses. And that's really just for obvious maintenance purposes, right? You don't want the fuses to be that first thing in to be unable to be isolated from within the panel. So it is the only device where I'm actually allowed to use trailing fuses to increase short circuit current rating. And non-fuse disconnects with trailing fuses, A lot of times I can get that 100 or 200 Ka rating with those kind of without a problem. And so when I use a non-fused disconnect, really, really important, there's two different UL ratings that you can have for non-fused disconnects. UL98, right? UL98, that's the good one, right? That's the top of the line level. UL98 disconnects can be used in feeder circuits. UL98 disconnects are, they have the spacing requirements that they need to be used as that main in that feeder circuit. And they have, there are limitations in there. They're rated for isolation. That's really the big thing, is so that it has provisions in there about the contacts being permitted to, not being permitted to weld during a short circuit, all of this. They are rated for isolation, which of course is exactly why you have a disconnect in your main disconnect in your panel in the first place. So it's an isolation rated disconnect. Probably one of the, this is again probably in my top two misapplications as an industrial control panel, is there are also UL508 non-fused disconnects, and UL508 non-fused disconnects can only be used in your branch or at the motor. UL508 are motor disconnects only. So that at the motor disconnect or in your branch circuit, it is rated for motor on off. It is not rated for isolation. It also doesn't have those spacing requirements that you need to be in a feeder circuit. So I see a lot of UL508 disconnects used as main disconnects, right? And obviously there's multiple manufacturers of these, so I see everybody's there. If it's a UL508, and people love these because they're tiny and they're inexpensive, but they're tiny and they're inexpensive because they have a limited use. So just know UL508 non-fused disconnect, branches only, or again that at the motor disconnect, that's really there's one of their best uses. So we don't want to see a UL508 disconnect as a main disconnect. That is a misapplication. But if I'm using a UL98 non-fused disconnect and I'm using those trailing fuses in that power distribution fuse block, I have a great panel set up already. So we're going to go ahead and assume that we've put that in here, right? So I've got my UL98 non-fused disconnect. It's got a 200 Ka short circuit current rating when I use trailing 100 amp class J fuses, and then I put that power distribution fuse block in there. They've got 100 amp, those are 100 amp fuses in there, short circuit current rating 200 Ka. That's really, really helped me out here, right? So now once I do this, once I do this, right, now my G was the primary protection for my control circuit, and then my main, anything in my feeder is going to be 100 or 200 Ka, right? All of them here are, in this case, 200 Ka. And this is a great, great spot to be in for your panel, right? Because that means that the short circuit current rating of your panel is going to be dependent on your branches. And the reason that's good is because the branches are usually right, the customer, what you care about the most, right? You want to make sure you're using a specific drive in there. You want to make sure you're using, specific starters in there. So whatever it is, usually if you or the customer has any preferences of what goes in your panel, it's in the branches. And then the short circuit current rating can be based all off of that. So again, that's a really, really great spot for you to be in your panel, just the short circuit current rating being based on your branches. You can sort of have a general template of your panel where you've got fused control circuit, this non-fused disconnect and power distribution fuse block as your main. And the other really good thing, and didn't even mention this, is a non-fused disconnect and a power distribution fuse block. It's going to be less expensive than a fused switch and a power distribution block and a regular one. You're going to get that high short circuit current rating and lower cost. And the non-fused disconnect is usually a lot of times it's a lot smaller than the fused version of that disconnect. So advantages abound when you use a situation sort of like this for that disconnect and that for that main protection and that main power distribution. So Now we're at the point in time here where my panel short circuit current rating is going to be based on my branches. So let's talk a little bit about the protection in my branches. Obviously, the big thing in my branch is, right, I can't go higher than the lowest interrupting rating. So it's really important that whatever I'm using in there has the high interrupting rating. I can use breakers. Just note that, right, if I want a 65 kA rated panel, I'm going to have to get a 65 kA rated breaker. 65 kA breakers, they cost more than the 10 kA breaker. But you could certainly, have breakers in that if there is a reason, if it has a really good rating with whatever is downstream. You can use something like a manual motor protector. Rockwell has a ton of these, right? So use this manual motor protector. It has some really good combination ratings with downstream devices. You use this, you're probably going to get between 42 and 65 kA. You're using a combination motor controller rating. Just couple quick notes about this. We talked about this in the last one, but you want to make sure you're using that line side adapter anytime you're using one of these. Without that line side adapter, you technically don't have short circuit protection. So make sure you use that line side adapter. And if you use one like this, you get a slash rating. So slash rated components make you have a slash rated panel, right? That 480/277. And those can only be connected to solidly grounded Y systems. So you just want to make sure you don't use slash rated components in a delta or really anything except a solidly grounded Y system. But they're great products and often work for they work in a lot of situations very, very well. And then finally, right, of course, you can have fuses. And again, those fuses can come in a variety of holders. Sometimes in your branch, you don't really need it to be a disconnect. You have other means of isolation that you do not need the disconnect to be there in your motor circuit. So you could use that UL98 switch there. We have the one that's shown there. That one, it uses Class CC fuses. It goes up to 30 amps as a result. We have a version of that uses our CUBEFuse, and that goes up to 200 amps. So you could use a fuse disconnect there. If you don't need the disconnect because you don't need the isolation, you have that somewhere else. You have a drive that connects as its own disconnect, whatever it might be. Then you can use any old fuse holder. You can use that one that rocks out, again, when you don't need it to be a disconnect and you're not worried about it being misapplied. Go ahead and use that rock out version of the fuse holder, or just a, sort of regular plain old fuse holder, shown there with finger safe covers. Any of those would be, perfectly fine in any of your in your branches, right? All just depending on your need for it to be a disconnect, and sort of the application of how you want to be able to maintain something.
Christy, we have a question in the chat box.
Okay, let me pull that up here. What would be the XCPR what would be the alternative if I have a Delta system? So if you have a Delta system, you can turn one of those products. So you can turn a slash rated component into a full rated component by fusing it first. So you basically add an extra level of fuses. Now you can do it in a couple ways. You could make it a group motor. So you could put one set of fuses and a whole set of your manual motor protectors underneath of it, and that actually turns all of those into a straight rated, or simply not using that and replacing it with fuses. So depending on sort of what would work better in there. But the way that you can turn it into a fully rated device by fusing it. Of course, sometimes that seems a little bit redundant to have fuses and then the manual motor protector. You can also just, remove the manual motor protector and put a straight rated component in there, whether it's a breaker or a fuse, and then you get it straight rated. But one of the easiest ways, if you have multiple manual motor protectors and you still really want to use those, is to put them all in that sort of group motor application. So you have one set of fuses and then all of those connected to it. That makes it a fully rated device. Now, of course, if those fuses open, you're going to lose all of your motors. So you do want to make sure you're in a system where that's okay, right? Some systems, that's fine. You get one short circuit, you want the whole thing to shut down. But sometimes that's really, really not what you want. So that's the really one cautionary piece of advice when I use a group motor instead. If you have a specific design like that, I've helped a lot of people who have been using ones like that comes up a lot. Please feel free to reach directly out to me and we'll figure out sort of which one is the best for your system. But usually the answer is to put a fully rated device in front of it, whether it's fuses or just completely replacing it with a fully rated component. All right, so I have gone in here and I have replaced the breaker with a fuse so that I have much higher rated components here in this case too. So right, I can see that I put my CUBEFuse CCP, so I actually put a disconnect switch in this circuit E. Right, I replaced that 22 kA rated breaker. My contactor now has a 35 kA rating with a 20 amp max class J fuse, so I've got that. I'm good. You can see here, right, this actually says, oh, it says with a class J fuse, but I used a CUBEFuse. But if you remember my exception from last week where I'm allowed to use fuses that have equivalent or less, basically the equivalent or better let through, right? So equally or better current limitation. So the CUBEFuse and a class J are equivalent. So anytime I see a class J fuse specified and I see it just specified as class J fuse, I can replace it with a CUBEFuse and you know, and be okay and still use that high short circuit current rating. So that's what I'm doing in this case. I'm using that exception. And the other good thing I get to use here is now I have a current limiting device in my feeder, right? I have current limiting fuses in B. So I can use my let through current here. My let through current at 100 kA is 14 kA. And that 14 kA will be less than that 35 kA short circuit current rating, right? So if my let through was 14, so now my panel short circuit current rating, right, I can make that branch 100 kA because that 14 kA let through is going to be less than that 35, and I can raise that up to 100 kA. Now I've got a 100 kA rated panel. So I can use that method to help me out here. Hypothetically, I could look up that value at 200 kA. It might still be lower than 35, and I can raise this panel up to 200 kA. But if there are very few times where 100 kA is not enough and you need 200 kA instead. If you ever run into those, then you're definitely using a whole bunch of fuses. And, oh, you know what I have? There we go. That's one animation short. So that's with my non-fuse disconnect, power distribution fuse, fuse block, and, you know, fuses all in my branches. Of course, I'm going to get a high panel short circuit current rating when I'm like this. In this situation right here, if I'm above 200 amps, I think for my main, I think this is my best solution today. But we actually, basically, Bussmann has come out with a better solution. In the past year and a half or so, there is an even better solution to save you sort of more cost and more space in your panel and keep your high short circuit current rating. And that, if you don't know it, is the, if you know, we talked about the CCP, the compact circuit protector, right? But what's really, really great, this product is really not new. What's new-ish now it's been around for about a year and a half, is the ability to use this with a through-the-door mechanism. And the ability to use it with the through-the-door mechanism, of course, means that now this can be a main disconnect. We've had it for about, 10 years almost without the through-the-door capability. So let's go ahead and look quickly here, right? So we talked about this CCP2 right here, right? Really great in front of control power transformers. Well, this is also the smallest 30 amp class CC fusible disconnect that you can buy. So you just add that little rotary mechanism there on the side, sort of your standard shaft and handle. You have a 200 kA short circuit current rating with this. Generally speaking, the cost of this is equivalent to a normal class CC fusible disconnect. So it should be really, really close. And it's 38% smaller. So for the same price, you get something 38% smaller than what you were using. And one of the really, really big benefits, which we'll go into detail later, is the ability to use multi-wire lugs on this. So we'll go through those multi-wire lugs sort of after I introduce any of the switches. But finger safe design, UL98 disconnect, rated to be that main panel. The Class CC obviously only goes up to 30 amps, and that's because Class CC fuses only go up to 30 amps, but it's the smallest 30 amp fusible disconnect that you can buy. And you get kind of all of the features that you would expect, you know, the lockout, you can get an NFPA 79 handle on here, anything that you might sort of expect in your fusible disconnect, this is going to have. Then you might ask, of course, well, what if I need, you know, this is great, very, very small 30 amp fusible disconnect, but what if I need more than 30 amps? Well, that's when we go into our CUBEFuse disconnect. So this is, if you are not familiar with the CUBEFuse itself, you know, was invented in the year 2000, so it is a pretty old fuse. It can vote. So it is a fuse that's been around for a while. It is equivalent to a Class J in every way except the holder that it fits into. So it is electrically the same as a Class J fuse. It is just physically different shape, and it would fit into this this holder here. So the 100 amp one, that's what I'm showing you right here. This 100 amp fusible disconnect is 51% smaller than a traditional 100 amp fusible disconnect. So half the size. It is half the size of a traditional 100 amp fusible disconnect. These also have that ability to put multi-wire lugs on it. So not only is it smaller, but then you use multi-wire lugs, and you can also maybe get rid of a power distribution block, save a whole lot of space. Again, the goal here is similar price to what you're already paying for a 100 amp fusible disconnect switch. So we have this for the CUBEFuse. You have the 30, 60, and 100 amp are your breaking points here for this fusible disconnect. And what's a really, really nice feature, I think, it's not on the next one, is that you can actually underfuse any of these. So to show an example of that later, but you can actually put any smaller amp fuse into this disconnect. So unlike if you had a 100 amp fusible disconnect today and you tried to put a 60 amp fuse in it, it wouldn't work, but you could put a 60 amp fuse in a 100 amp disconnect with this style. So I'll show you kind of how that works a little bit later here. But again, 200 KA, short circuit current rating, half the size of those traditional fusible disconnects. Really, really big deal. The 30 and the 60 are the same width as this one shown, but it's a little shorter. But otherwise, it's about the same. Why would I use a 30 amp version of this CCP instead of the 30 amp Class CC? There are a few reasons. One is the CUBEFuse version has some better horsepower ratings. So if you need it to be a motor disconnect, it's got higher horsepower ratings on the CUBEFuse version, and you have some different accessory options. So maybe if you needed some of those accessories, that would be the reason you'd use the 30 amp CUBEFuse instead of the 30 amp Class CC one. There's a non-fused version of this as well. It's the CCD, that stands for compact circuit disconnect. High short circuit current ratings when you use the trailing fuses, otherwise it's 10 KA. Really good benefit of this is that it is the exact same size as the fusible disconnect. So if you happened to, maybe you have some design where, sometimes you have a non-fused disconnect and sometimes you have a fused disconnect. And with traditional non-fused and fusible disconnects, there's a really big difference in size that you get between the two. But this could make it so that you have the exact same footprint and that interchangeability, for the non-fused and the fusible. So it can be a really big advantage if you happen to have a design where it is sometimes fusible and sometimes non-fusible. And this is a lot smaller even than your traditional non-fused disconnect. You can see it's basically the same thing, it's just the fuse pieces covered up. Here's that piece about the flexibility of the CUBEFuse. So one footprint can give you 1 amp to 100 amp. So you can underfuse any of these. So I can you can see there's 100, 60, and 30 all within this one device. So I've got one of the first adopters I had of this switch is somebody who builds machines, and their main disconnect always winds up being either 60 or 70 amps. And so they had to stock both 60 amp switches and 100 amp switches because, you know, it's sort of 50-50. But what they did was they just switched to all 100 amp switches and put in a 60 or a 70 amp fuse depending on what they are. So it can, if you're in a situation sort of like that, that can really, really help you out. You know, eliminating a part number, especially because the 100 amp switch is, you know, not even, it's taller than the 30 and the 60, but it's not any wider. So, you know, you barely give up any panel space to be able to do that too. So it's a really, really big, big deal. You don't need any fuse reducers to make this happen. So 30 amp switch could do 1 to 30 amp, 60 goes 1 to 60, 100 goes 1 to 100. So you get all of that interchangeability, sort of. You can always underfuse this switch. There's a side rotary option. So the ones we saw before were rotary, but it was rotary through the front. So you can get these. Really important to note that if you are going to buy this with a rotary, you must buy it with the rotary already on it, specified the way you want. So you can get that on the right, you can get it on the left, you can get it through the front, you can get it through the side. This is the side option shown here. So you can get any of those, but the way you order it, there's no changing it in the field, so that you have to order it the way that you want it. So side rotary option, also an availability as opposed to just the front. You can also write any of your handles. Now this is sort of all your sort of standard. There's a defeatable interlock, type 1, 4X, and 12, red, yellow, black, gray. We have an NFPA 79 handle on there, so that gives you the ability, right, that slips onto the shaft and lets you operate it with the door open, which is an NFPA 79 requirement. And then you get the, and it's an 8mm shaft with 2 different lengths. So depending on the depth of your panel, you can get the right shaft for the length. And a lot of times, right, those can just be cut to the exact length that you need them to be if they're too long. You can get flange. The flange handles are I believe these are not actually available yet for the 100 amp and lower. They're available for the higher amp ones, but they are supposed to be really, really soon. So if you want to use a flange handle, just check in, and it might be available by then. These are like really, really close. So flange handles available. Now these are only available for the CUBEFuse versions. That Class CC version will never have any sort of flange handle. So flange cable or flange rod, it's going to be rotary only, and that's primarily just because that's such a small, inexpensive switch that if you put a flange handle on there, the flange mechanism would cost more than the switch. So the flange is only going to be for the CUBEFuse version. And these, again, I don't think these are available today, but they're very, very close. Then this is the big seller here, right? Multi-wire lug kits. So the multi-wire lug kits could eliminate the need for a separate power distribution block. So the multi-wire lugs can be installed on the line or load side. Most of the time you're going to get it on the load side, so it basically acts as that power distribution block. Dual conductor rated, again, between 10 and 14, so 2 identical conductors between 10 and 14. If you're in the 30 or the 60 amp switch, and this goes for the Class CC version or the CUBEFuse, you can get 3 ports per pole. And all of these come with that shroud, so you can keep it finger safe. That finger safe shroud comes with it when you order it to keep it that way. And then if you get the 100 amp switch, you can get the 6 ports per pole. Another really good advantage of being able to underfuse that 100 amp switch is sometimes you need 6 ports and not just 3. Well, you could get the 100 amp switch, get the 6 port multi-wire terminal, and then just underfuse that switch, right? You could put a 60 amp fuse in there if you needed to. So that is another reason we see some people underfusing that switch. So you can imagine, right? This product already, this switch is 50% smaller than a traditional fusible disconnect switch. Now if you put these multi-wire terminals on them and you eliminate the need for a power distribution block, you're going to save yourself the labor of wiring to that power distribution block and the space and cost of it. These are a lot less expensive than a power distribution block, so you save yourself the space that would have taken up, as well as the cost. So really, really great. Being able to use this with the multi-wire lug kit is a really, really great thing. Another accessory that you can get is a PLC fuse monitor. So this actually monitors the health of the fuses. It will let you know, it will send a signal to let you know that a fuse has opened. So it's got it's 24 volt DC, and it can send a signal again to your PLC to actually let you know that a fuse has opened. Important thing about this is that it mounts on the left side only, so if you're using a side rotary switch, you need a right side switch. It doesn't kind of work with across that disconnect, so you have to use the mounted on the left side only. You need a right side disconnect if you're going to use this. The aux contact is the opposite. It mounts only on the right side, so if you want a through the door mechanism and an aux contact, you need that to be a left side switch. And the aux contact, that just it measures the position of the handle, right? It tells you if the handle is up or if the handle is off. It doesn't actually tell you anything about the fuses. PLC fuse monitor measures the health of the fuses. Aux contact just is the switch on or off. There's my size comparison here, right? So 43% smaller footprint than a traditional Class CC disconnect. This cost savings, I believe, is based on $5 per square inch in a panel. So you'll see that cost savings on a couple of these, but $5 per square inch, and some rounding, I think, was here. This is my CCP size comparison for the 100 amp, right? 51% smaller than a traditional 3-pole Class J disconnect. Cost savings, and again, that's not even counting if I'm using multi-wire terminals. And then finally, there's a 200 amp version of this as well available. So the 200 amp version is 69% smaller than a traditional fusible disconnect switch. So it is incredibly smaller. It is actually, if you are familiar with Eaton breakers, it is the size of a JG breaker. So imagine that is way, way smaller than we are used to seeing for fusible disconnects. So 69% smaller than traditional fusible disconnects. You still get all of those benefits: 200 kA, short circuit current rating, fuse interlock, multi-wire lug kits available, all of that for this disconnect as well. Non-fused version, I'm just going to speed through that, but it's an exact same footprint again as the fused version, and that high short circuit current rating available with trailing fuses. For this one, the mechanisms are separate. So if you remember, for the 100 amp and smaller, if you wanted a rotary mechanism, you had to buy it with the rotary mechanism already on there. For this, it's separate. So kind of like how you would do with a breaker where it's module, right? You would get a separate front rotary mechanism for it. So this is how you do screws right there onto the front of it. It works really well. I actually have a box that has this in it. It works really, really well on this fuse. There's a side rotary mechanism available as well. So if you are a side rotary mechanism person, rotary handles, basically the same thing we had before, and an NFPA 79 compliant handle available. Flange handles are available for the 200 amp today. So if you need a flange, either a flange cable or a flange rod, those are available for this 200 amp. So for this one, you just buy the regular switch and you add in this flange kit. So you can get these today. Really, really great solution again for that main disconnect. And if you're buying your enclosure with the hole cut out, I believe it is the Westinghouse cutout for your flange handle. I think there's a couple ones in there, but there's like a Westinghouse / Eaton / it's that hole, and it fits in. There's a universal one with a plate that you can get from a lot of the enclosure manufacturers too. It'll work on that one too. So either the universal one or the Westinghouse / Eaton flange handle cutout. And then there's multi-wire lugs available here. So you can get 3 ports per pole of a larger, wire sizes, or 6 ports per pole, for some of the smaller ones. So both of those available, and again with a finger safe cover on top of it. So that shroud comes with the lugs when you get them, so you don't need to order them separate. and 200 kA short circuit current rating even when you use those. That's true for both, for any amp rating of these. And then finally, this one has a aux contact as well. This aux contact can mount on either side, so you can put on the right or on the left. And it measures, again, the on-off of the switch, or the position of the handle. There is no PLC fuse monitor for the 200 amp. You can get a separate terminal shroud, not, so you could get it with the lugs, but you can also get it separately if you just wanted one, or if you lost it. There's phase barriers available too, so if you want something like that, maybe you want that on the line side of it, you can get these phase barriers, and then you can also get this handle extension. So the operation of that switch, now we think most of the time a 200 amp fusible switch, that's going to be a main disconnect. And when it's a main disconnect, it's going to have some sort of through-the-door mechanism on it that's going to provide you the leverage you need to be able to operate the switch easily. If you're not using it with a through-the-door mechanism, it is a little difficult to switch. Typically when I, have a sample of it and I pass it around to a classroom full of people, all of the big strong men in the class, they can operate it with a little bit of difficulty, but they can operate it. I have a hard time operating it myself, but with this handle extension, it's super easy. So if you happen to be using it and it doesn't have a through-the-door mechanism on it, you might want this handle extension. It'll make it a whole lot easier to operate the switch. It's really easy once you have that handle mechanism too. So here's the size comparison, right, for my 200 amp. It's so much smaller, right? It's about half the width and it's shorter. Save you a ton of panel space. And again, this is before we even count multi-wire terminals. So really, really great product here. People are really, really loving, especially this 200 amp. This 200 amp version saves you a lot of space. And again, pricing wise, we're matching it up to roughly what you would pay for a 200 amp version of a switch now. So you get that much, much, much reduced space for the same price that you paid for the much larger product. And then just with that, right now we've got the CUBEFuse, which we talked about, very electrically similar to the Class J fuse, and the CUBEFuse comes in just holders as well, right? So you don't necessarily need it to be in the switch. The really, really great thing about the CUBEFuse holders is that they are finger safe without any additional covers. So if you're buying a CUBEFuse in a holder, you only need to order 2 part numbers, just the holder and the fuse, as opposed to holder, fuse, and cover in order to make it finger safe. And one thing I always hear about finger safe covers for fuse holders now is that, right, the first, you ship it out with the covers and it's perfect. And the first time someone takes those covers off to work on the machine, they never get reinstalled, right? They wind up in the bottom of the panel. They wind up thrown out. Those finger safe covers don't always get reinstalled, but these are going to be finger safe inherently, right? So just if the fuse is in there, you're going to have that finger safe construction. So really, really great product for that reason. The 225 amp and 400 amp version of these, so this actually goes up to 400 amps in the holder. They have a lockout capability as well. So if you need to be able to lock them out, the 225 and the 400 amp have that capability. They're also tiny, as you can see here. The 30, the 60, the 100 amp, right? That holder is the same size as the fuse, so you're not adding any space around it. The 30 amp fuse holder is actually the same size as some Class CC holders that are finger safe. So you can save yourself just a lot of space. They can be mounted right directly next to each other. 100 amp and smaller DIN rail mount. The 225 and 400 are direct panel mount, but can really, really save a lot of space by using these two. And above the 100 amp, so in the 225 and the 400 amp, you can get the multi-wire terminals, so you can use them as that like power distribution fuse block again. So right, some key benefits of this product line, right? You save a ton of panel space, increase your short circuit current rating because they're current limiting. They'll have really good ratings with your downstream fuses, and they themselves have a high short circuit current rating. You can have enhanced flexibility since you can underfuse any of these. Save yourself money and labor by eliminating the power distribution blocks and using multi-wire lugs. 200K, right? It's a UL98 switch, so it can be used in that main. It's 200K rating, so really, really good benefits to using these. Really going to help you with your panel short circuit current rating and fit everything into a smaller panel size. So with that, now I'm putting this in here. This example, I've actually used the CUBEFuse with the power distribution block because that power distribution block will have a higher rating with this. Maybe this was an example where I needed more ports than what I could get out of my switch. So that's why I went to a power distribution block. But again, multi-wire terminals would be sort of even a better option here. Now I get my high short circuit current rating, and I've greatly reduced the amount of space in my panel that I needed in order to get there without negatively affecting my cost. So really, in summary here, right, my keys to achieving high assembly short circuit current rating: I want high interrupting ratings. I want high interrupting ratings in my branch and in my feeder. I want high fault ratings for all of my short circuit current ratings in my branch and in my feeder. And then again, I can use that step 1B, that increasing my branch component short circuit current ratings with a current limiting feeder, if I'm applying that correctly. So hopefully, this is sort of my summary, is we're hoping that everybody on this call, is no longer going to make a 5K rated panel, right? I always say a lot of times when you have a 5K rated panel, it's either because you're mixing manufacturers, maybe you don't even bother to calculate the short circuit current rating, it hasn't been a big deal, so you just stick 5K on there because it's the minimum. Or maybe it's because you don't know how to get anything higher, and none of those should apply anymore. You should know how to get higher. You should know how to calculate it. We also don't want you to do this. So this is an example of somebody who labeled their control panel 100 KA, but their actual short circuit current rating was 5 KA. They had a misapplication of their current limiting feeder in their main, and then they assumed a much, much higher. So, I guess if you're going to have one that's actually 5 KA, it is better to label it 5 KA than to mislabel it 100 KA. But I really want you to properly apply all of these rules to get the correct short circuit current rating. Do not misapply that current limiting feeder rule. And so this is really what we kind of suggest for everyone. So maybe now you go back and you have your original design and you look at it and it's 5 KA. And you say, well, I can maybe just one small change and I can get this to something higher. Maybe I can get it 35 KA. Figure out what a standard short circuit current rating would be good for you. Take a look at any time somebody has asked you for a higher short circuit current rating, what rating has that been? Has it been 14 KA? Has it been 22, 35, 65? And make that your new standard, just so you know that, you can get some sort of economies of scale going for you if you say, well, especially if it's easy to get there, right? One small change and all of a sudden you've got that, maybe not even that much increased cost, and you've got all of your designs are going to be, say, 35 KA. And then importantly is know what you would have to do to get it to be a higher short circuit current rating. So not necessarily saying you should make every single design 100 KA all of the time, but in the event that somebody comes to you and says they need that, just know that you would be able to get there, how you would do it, how you would be able to get there. Because I could tell you there's a really, really big advantage, over a competitor if they say, we need a really high SCCR design on this, and you can just turn around immediately and be like, oh, this is what that design would look like, and it is $500 more adder just to be able to do that. Whereas your competitor has to redesign their whole machine, takes them 2 weeks to get by, they've already put the PO in with you. So really, really big advantage if you just know what to do to get that higher short circuit current rating, out there in the market. So with that is pretty much it for me. We're a summary of everything here, right? In my design and proposal phase, I want to make sure I'm asking for the SCCR requirements. It's hard to build to an SCCR requirement if I don't know what it is. So ask for that short circuit current requirement. If you remember from the first one, it's an NEC requirement, that the available fault current. So know the available fault current, ask them for that short circuit current rating requirement. determine a standard short circuit current rating level, whatever that is for you that makes sense. Some of you it might be 65 kA, some it might be 18. Just depends on what type of equipment you build and where it's normally going. So determine that standard short circuit current level. I'm just asking you that it's higher than 5 kA most of the time. And then in review and analysis, right, we want to look for the lowest rated short circuit current rating or interrupting rating. I cannot make my panel short circuit current rating higher than that. And then finally use those high fault short circuit current components and current limiting overcurrent protective devices to give me the highest short circuit current rating. So with that, that is all I have. I will send to Nicole, again, a copy of this presentation along with some of the links and brochures and stuff for some of the products that we talked about. If you have any questions, you can feel free to reach out to Nicole, reach out to me, reach out to your sales rep, and we can talk about all of these products. I'm going to go ahead and monitor the chat. If you have any questions, again, now, feel free to ask away. But otherwise, I really, really want to thank everyone for joining me for this series. And, I hope you guys have a good rest of your week. And again, I'm available for any questions outside of this call as well if something comes up later.